So we're going to start now back in it with Harrison Smith from the School of Marine Science and Policy. Harrison, the time is yours.
Thanks. We've all heard that robots are taking over the job market. But what if I told you that retail and manufacturing aren't the only industries where robots are making a splash? Oceanography has been revolutionized with the advent of high-tech observatories that allow people like you and me to see the ocean in ways that people 50 years ago could only dream about. Today, we have robots that dive thousands of meters below the ocean surface, and robots that can see a centimeter from an orbit thousands of miles away. Now, we don't always think of satellites as robots, but they are. And for oceanography, they provide an unparalleled daily global snapshot of the world's oceans. But when it comes time to validate the data from these multi-million-dollar taxpayer-funded ventures, we fill a boat with people, fuel, scientific instruments, and we send it to the middle of the ocean to repeat the satellite's measurements. Sound expensive? Tedious? I think there's a better way, one that uses the tools we already have. My research explores using underwater robots called gliders to validate data from ocean-observing satellites. Now, gliders are already taking all the same measurements that are taken on a satellite validation cruise at a fraction of the cost. If we can use the resources we already have more efficiently, satellite oceanography can rocket forward and leave the tedious jobs to the robots. Thank you.
All right. Thank you, Harrison. Very well done. Next up, we have Jinghua Zhang from the Department of Civil and Environmental Engineering. So, Jinghua, it's your time.
Thanks. Hi, everyone. Are you ready to enjoy the beer, food, and water tonight to get more energy? Well, yes, I am. We all need water, food, and energy. So the needs for these three resources are increasing. So let's do some brainstorming. Do you have any idea to reuse water, produce more food, and save the energy at the same time? Well, yes, we do. Tonight, I'm going to share you a powerful technique. Let's follow our steps. First, we convert the agricultural waste, such as corn straw, grass, wood, to become functional charcoal. Yes, charcoal, the one you use for barbecue. Second, we clean the water, make it reusable by electron sorption combined with functional charcoal. And at the same time, we concentrate the nutrient from the wastewater onto the charcoal. And after that, we apply this nutrient charcoal as a fertilizer to increase the food production. And eventually, we convert the agricultural waste, become a new resource, form a cycle, save the energy of the world. So let's follow our steps. First, use the charcoal, clean the water, produce more food, and save the energy by one simple technique. Thanks.
Thank you, Jinghua. Next up is Matthew Vaughn from the College of Earth, Ocean, and Environment. Matthew, time is yours.
So, we all know how after a few beers, our behavior changes, often drastically. We get drunk. Likewise, clownfish are getting drunk off of our carbon dioxide or CO2 as a result of climate change. Now, I don't mean drunk as in a euphoric party, woo, drunk. I mean their behavior is impaired. Just like how a drunk person can often overestimate their ability to do things, increased CO2 in the ocean can have a similar effect on clownfish. For example, they can become much bolder, leaving their habitat for longer periods of time and exhibiting risky behavior that they would not normally do under sober circumstances. Sounds similar to liquid confidence? Again, like a drunk person, they don't perceive things the way that you normally would under normal conditions. Yep, sorry, I messed up.
All right, give him a hand. Nice job, Matthew. Next up, we have Piyush Kalasi from the Department of Agricultural Economics and Applied Statistics. Piyush, it's your turn.
Every individual consumes agricultural products daily. So we can ask, what motivates towards your purchase of food products? And then we think, do you prefer to understand how are they produced? Are you aware about genetic modified food? If you are given to choose between genetic and normal or natural, which could you choose? Food and Agriculture Organization estimates the world population to be 7.8 billion. It's expecting to increase to 8.6 billion by 2030 and 9.8 billion by 2050. Food demand is increasing, while the land for producing agriculture remains the same. And it's producing less today than previous years because of being cultivated for a long time. Producers are using fertilizers and chemicals to produce in order to meet the demand. Introduction of genetic engineering aims at increasing productivity while eliminating the consequence of excess use of chemicals for consumers. Now, my research is expecting to help producers to know how they can produce better food which is safe and good for consumption. Thank you.
All right, thank you, Pius. Next up is Jennifer Joseph from the School of Marine Science and Policy. Jennifer, the time is yours.
When you're a kid, you dream about being an adult, dressing up in your parents' clothes, acting like an adult, to planning your dream house. But you're just a kid, and you have to wait to grow up to live that dream life. Well, baby coral reef fish know what they want to, but they have to grow up before they can live on their dream reef. They aren't quite ready for the adult reefs and don't want to risk getting eaten. These baby fish have to navigate these reef systems to find a good place to grow before living their dream life. My research is looking at where these fish live as babies versus adults, and how these fish pick their dream reefs. And by surveying reef fish communities, we can better understand where fish prefer to live as babies and as adults, and what features of the reef these fish look for in their dream reef. Do they prefer a little bit of hard coral or a little bit of soft coral, or do they hate some sponges? These baby fish may not live on adult reefs yet, but they have to know what to look for when they do move to an adult reef. But coral reefs are changing, and the foundation species that make up these reefs are shifting. And if reefs shift to having more of something fish don't like, they may not want to live on those reefs. And by understanding how fish pick between these different reefs, we can better understand how these communities may change in the future. And just like when you're a kid and you're planning your dream mansion and you know exactly what you want in it, baby coral reef fish know exactly how many soft corals and exactly how many different hard corals without any sponges they want on their dream reef. Thank you.
Thank you, Jennifer. Well done. Next up, we have Emma Stell from the Department of Geography. Emma, the time is yours.
Psst. Hey, can I tell you something? Future climate projections are hugely uncertain. And one of the biggest reasons for this is that soil respiration, the second largest flux in the carbon cycle, has huge uncertainties associated with global estimates. Soil respiration is the flux of CO2 from the soil to the atmosphere. To give you an idea of the implications with climate change, soil respiration emits roughly 10 times the amount of CO2 as do humans every single year. So this means even small changes in the overall amount of soil respiration can result in huge increases in the amount of CO2 in the atmosphere. Similarly to the stock market, where economists attempt to predict trends based on input data, in order to predict climate trends, we too need the best available input data from all over the globe. My research attempts to decrease the amount of uncertainty associated with global estimates of soil respiration. See, points are frequently being added to a global database, but are we really going to improve estimates if we keep adding points in the same places where we already have hundreds of measurements? Probably not. So my research not only attempts to map and quantify global soil respiration and its associated uncertainty, I also aim to identify the best future places to measure soil respiration. So while we may not ever be able to truly identify or predict the stock market, we can attempt to identify.
All right. Thank you, Emma. All right, next up we have Anish Kumar Soman from the Department of Geography as well. Anish Kumar, the time is yours.
Good evening, everyone. Have you ever wished the solar panels on your rooftop were more efficient and cost-effective? Well, 95% of these cells are made up of silicon. However, even the best technology, called as heterojunction, has loss mechanisms. Now, imagine them to be like lasagna, having layers of amorphous and crystalline silicon. Now, when light is incident on them, they excite electrons which jump from one silicon to another to generate electricity. But there is a problem. These materials have defects which act as sinkholes for electrons. That's where my research comes in. Like Tony Stark working on his arc reactor, I suit up in my lab coat, and then on the plasma reactor, I take the smallest atom that we know, which is hydrogen, and give it that right energy so that it slides into these atoms and heals these defects. I'm developing a process which is commercially scalable and only takes 30 seconds. You heard that right. So the next time you think about increasing efficiency, you know that all you need is these tiny hydrogen atoms and 1/3 the time for this pitch to actually make a better solar cell and a greener world. Thank you so much, everyone, for your time.
All right. Thank you, Anish Kumar. Next up, we have Melissa Langer from the Department of Applied Economics and Statistics. Melissa, the time is yours.
All right. How many of you have ever been in this situation? You've been really hungry, craving something, let's say pizza, all day. You and your friend, you go to the pizzeria, you're about to order, and you look at the menu. Whoa, that price is way too expensive. So you think about another option you could choose, but your friend, in the meantime, orders that expensive pizza. Wait, now the decision's not so easy. Your once really expensive pizza doesn't seem that expensive anymore. Your friend thought it was good enough for them, so maybe it's good enough for you too. And it's that influence that your friend just exerted over you that fuels our research. Our study is all about how social networks and social interactions affect food purchasing behavior. And we're looking specifically not at pizza, but at 3 other food commodities: oysters, mushrooms, and chocolate fondue, and a range of other network relationships. So not just your best friend, but maybe your mom, your dad, your roommate who you may or may not like, and what about a complete stranger? Do all those, would they influence you differently? Maybe. That's what we're trying to figure out. So in our study, we're trying to look at how that influence can be exerted and how that changes with different dynamics and factors. And that it's really important for us. We're trying to see how we can help better market these items so the industry can better use social networks and peer influence to better help make these products more successful. So maybe the next time you're at the food market or at that pizzeria and you have a decision to make, you can say with confidence, hey, waiter, we'll take 2 slices.
All right. Thank you, Melissa. Next up, we have Thang Nguyen from the Department of Biological Sciences. Thang, the time is yours.
Prostate is male reproduction organ. You either have one or know someone has one. But you may not know prostate cancer affects 1.2 million men worldwide. And here in the United States, prostate cancer is second leading cancer-related cause of death in men, and is #1 in new case diagnosis. Thanks to new treatment and early detection, prostate cancer can survive. 98% of patients with localized prostate cancer can survive. But 32,000 men didn't make it last year with metastatic prostate cancer. So that is the true killer. Metastatic prostate cancer is non-random. 90% of them travel to the bone where they cause pain, spinal cord compression, and pathologic fracture, which reduce patient quality of life and eventually death. But even though the clinical consequence is well known, but the underlying mechanism of traveling to the bone is not well understood. That is where my research coming in. We have been revealed that the initial negative interaction between prostate cancer cell and bone microenvironment, as well as identify Fiblin 1D as the candidate that can induce prostate cancer cell death. So further studying that can open new treatment as well as diagnostic marker, which give the patient big relief and clear direction in their treatment. And together, let's save the prostate. Thank you.
All right, thank you so much, Thang. Next up, we have Emma Smith from the Department of Civil and Environmental Engineering. Emma, the time is yours.
Have any of you ever eaten from a pizza box? Gotten Chinese takeout? How about cooked in a Teflon pan? Then you've come in contact with perfluorinated alkyl substances, otherwise known as PFAS. These chemicals act as water and grease repellents, as well as flame retardants in materials for clothing and furniture. They're also used in industrial firefighting foams because of their ability to form films on surfaces, preventing fire reignition. PFAS are environmentally persistent chemicals, especially because of their ubiquity in everyday products and their affinity to accumulate in the body. Certain PFAS have been linked to human health concerns, including thyroid diseases and birth defects. So what are PFAS? They're large molecules comprised of many carbon-fluorine bonds. The chemical bond between carbon and fluorine is extremely strong. In fact, it's the strongest organic bond that there is. So the more of these bonds that a PFAS molecule has, the stronger and more difficult to degrade they become. Because of this, there are currently no known methods by which to completely break down large PFAS molecules. My research aims to develop a cheap and scalable process using physical and biological methods to completely degrade these PFAS compounds. The physical method uses aluminum nanoparticles to degrade the larger PFAS compounds to smaller compounds.
Thank you, Emma. Well done. Next up is Jocelyn Wardrop from the Department of Plant and Soil Sciences. Jocelyn, the time is yours.
Hi. Carbon is the fourth most abundant element on the globe. It is essential for life, but it can also be detrimental. Carbon is important in atmospheric processes regulating the atmosphere of the globe. How we manage carbon is very important. We've all heard about adapting eco-friendly lifestyle changes to help with the regulation of carbon entering the atmosphere. These adaptations usually involve limiting your fuel consumption for limiting the release of carbon entering the atmosphere. But what if there's another way to save the planet? Soils contain the largest terrestrial sink of planetary carbon. How we manage soils are very important for the release of carbon into the atmosphere. Wetland soils in particular have the ability to continuously store carbon and sequester it. If soils are mismanaged, soils may release carbon and wreak havoc on our lives. My research involves mapping and interpreting soil carbon stocks. Just like you have insurance on yourself, your home, your property, maybe even your life, quantifying how much soil we have for future climate change models and also for management decisions is very important. Hopefully, my research will lead to a greener future for all of us. Thank you.
All right. Good job, Jocelyn. Next up is Rachel King from the Center for Experimental and Applied Economics. Rachel, the time is yours.
If you've been around farms, you may be familiar with the springtime manure aroma that permeates the air. Most people complain, roll up their windows, and hold their breath as they pass by. But to individuals in the agriculture industry, it's the smell of money. Delmarva, Delaware, Maryland, and Virginia has a lot of poultry producers, which means we have an abundance of chicken poop. Animal manure is a valuable source of nutrients and is commonly used by farmers to fertilize their crops. But applying too much manure in concentrated areas can negatively affect local watersheds through runoff and nutrient overload. The goal of my research is to identify cost-effectively ways to move manure from high nutrient areas to low nutrient areas where it's needed. I've been interviewing poultry producers, manure brokers, and crop growers to understand the distribution of poultry litter in Delmarva. I found that crop growers in non-poultry producing areas with low nutrient levels can't find farmers who are willing to transport and move manure at a reasonable price. The farther away they have to move, the higher the price of the manure. For those farmers, it's more feasible to buy cheaper synthetic fertilizers. Results of this study will help us find cost-effective ways that benefit poultry producers, manure brokers, and crop growers. It may smell a little bit more in the spring, but it supports productive agriculture, protects our environment, and improves our water quality. Thank you.
Thank you, Rachel. Well done. Next up is Matthew Walter from the Department of Geography and Spatial Sciences. Matthew, the time is yours.
Delaware is very wet. So wet, in fact, that over 25% of it is covered by wet areas referred to as wetlands. Whether or not we know it, wetlands have a great impact on all of our lives. Wetlands are attributed to creating $4.9 trillion worth of ecosystem services each year. Wetlands are referred to as nature's kidneys because they regulate pollutants that are entering the waterway. Even though the great benefits of wetlands are widely known, we have still seen a large-scale destruction of wetlands since the turn of the century. It has been estimated that between 64% and 71% of wetlands have been destroyed since 1900. Even if wetlands are not being destroyed completely, we're still seeing large-scale degradation of these wetlands. I'm sure we've all been driving down the highway and seen a small puddle or pond on the side of the road that is just completely covered with trash and other litter. In my research, I hope to analyze this wetland stress, which is the human's impact on wetlands, using satellite data. Through the creation of an index, we can map stress that is occurring to wetlands, and this map can be used by policymakers and decision makers when making policy decisions related to wetland regulations. Thank you.
All right. Thank you, Matthew. Next up, we have Latoya Irvin from the Department of Plant and Soil Sciences. Latoya, the time is yours.
Thank you. Okay. I want everyone to close their eyes and imagine that you're at the beach. Imagine you're running towards the ocean, you jump in, and you get a mouthful of seawater. And it almost shocks you because it's just that salty. Then you finish playing in the ocean and you realize that your skin's a little wrinkly, you're slightly dehydrated, and you're pale. Well, ladies and gentlemen, these are the effects that salinity has on the human skin. Salinity is a common abiotic stress in plants. Not only does it inhibit the plant from uptaking. Salinity is a common abiotic stress in plants. Not only does it hinder the plant in uptaking nutrients from the soil, it also creates an imbalance in osmotic potential, and it also redirects the energy from metabolism into the excretion of sodium ions. So with climate change and rising sea levels, many crops have been introduced to saline soils and water. Now that same shock that you just received, plants received it as well. But unlike humans, plants can't grow legs and relocate. So wheat is one of the most important staples in the world. Wheat can be used for food, feed, seed, and fuel. Now, one might ask, how does salinity affect wheat? With my research, it won't.
All right. Thank you. Thank you, Latoya. Next up, we have Nyasha Shumayarewa from the Department of Plant and Soil Sciences. Nyasha, it's your turn.
Climate crisis and global warming are two of the biggest challenges that are facing global food security today. We see in Vietnam, rising sea levels are causing salinity problems on agricultural land. In countries like South Africa, Zimbabwe, Malawi, continuous droughts, as well as extreme temperatures, are reducing farmers' productivity. So regardless of all these challenges that we are facing, come the year 2050, we still need to produce enough food to feed the almost 10 billion people. So one would wonder, how is my work with Phragmites, invasive Phragmites to be precise, correlated to food security? So you know what's funny and interesting at the same time? Is that this Phragmites that you see driving around Delaware on the roadside tolerates all types of climatic conditions. It grows in high salinity soils, high pH soils. It grows in pretty much any place, anyway. And that's interesting, because I'm going to use my work to understand how the genetic mechanisms that influence this abiotic stress tolerance could be used in our own food crops. So transforming that or translating that information into something that we could use to engineer our food crops to be grown in places we used not to be able to grow them. Who knows? Maybe in the future we might need to start growing our corn in Alaska or maybe wheat in Arizona. And that's what's funny and interesting because my work is making that first step to make that a reality. Thank you.
All right. Thank you, Nyasha. Okay, before we end, we've got one more. Eric Munoz from the Department of Kinesiology and Applied Physiology. Eric, time is yours.
In 2010, over $20 billion was spent on health-related costs related to head impact. Typically, soccer is seen as safer than football. However, heading a soccer ball can generate forces that are equivalent to a helmet-on-helmet tackle. What's concerning is that soccer players can receive these subconcussive hits as many as 2,000 times over the course of their lifetime. The high prevalence of these repetitive head impacts is concerning given their association with short and long-term neurological consequences such as cognitive impairment and white matter alterations in the brain. An article published in the New England Journal of Medicine just last month showed that soccer players have a higher neurodegenerative mortality when compared to the general population. However, current clinical measures lack the sensitivity to detect subtle changes in neurological function associated with head impact. So what can we do? So I use nano-sized vesicles isolated from blood and saliva, and these vesicles contain molecular cargo inside. And inside the cargo is DNA, RNA, and protein. And what's valuable about this diagnostic information inside of these extracellular vesicles is that they can give us the status of the cell that they originate from, and in our case, that would be neurons from the brain. Thank you.
All right, thank you, Eric. Well done. All right, keep it going. Give them a big hand. Give everybody a round of applause. Well done.
We at Denon think that communicating our science and engineering and research is so important. It's such an important skill. And you all really did an amazing job. So I just want to tell you how impressed I am, and I think we all are. So give a hand to you. And so I have the pleasure of announcing the winners. And I'll start with our two fan favorites. The prize for fan favorites is $50. And that goes to Samantha Bingaman and Jinghua Tseng. Congratulations, you guys are it's for you. Congratulations. And stay up here because we'll have pictures. Our third place winner is Alex Muniz. Alex? Did he leave? Oh, okay. Well, someone can give him his $100. If you're trustworthy, we'll see. Yeah. We'll hold on to it. Okay. The second place winner is Anish Kumar Soman. Oh, and that's $300. So these are pretty good prizes, worth your while. Congratulations. Stay up here. And the big first prize winner, $500, is Harrison Smith.
Thank you.
Awesome job. There you go.
Thank you so much.
All right. Thank everybody.